we discussed about the absolute loaders. Absolute loaders are specifically used to load the operating system or startup routines to the specified address. Then we discussed about the design of absolute loader and the algorithm of absolute loader, how exactly it works. Moving further, we discussed about the Bootstrap loader. The Bootstrap loader is an absolute loader which loads the operating system into the specified address from the specified device. So the algorithm for absolute load means the Bootstrap loaders we just discussed with a program as an example, and the program itself is acting as an algorithm for Bootstrap loaders, wherein it reads from the device called as an F1 and loads it into the location 80H, and it skips those lines which are empty, means which is less than 0, and it shrinks the bytes that is read into half bytes, that is 4 bits, which we call it as hexadecimal character representation. And it loads the object code into the specified memory location, which uses a function called getC to read the character. And so when it is reading the object code, either it reads the numbers from 1 to 9 hexa, or else it is going to read A to F hexa. So we identified what is being read as a character, and relevantly the shrinking will happen and will be loaded onto the specified location. These loaders, either the absolute loader or both are same, absolute loader and Bootstrap loader. The implementation of absolute loader itself is the Bootstrap loader, and we learned about the algorithm, how the Bootstrap loader works. And then we went to the machine dependent loader features. One is the reallocation. So if the external references are there, it will be resolved by using reallocation bit or reallocation record, which we have seen from the assemblers also. The record specifies the operand address which has to be modified according to the start address of the program. So use of modification bit is good with the SIC-XC program, because we need the modification record for only format 4 instructions or which uses direct addressing, because majority of instruction in SIC-XC are either register to register operation, or it is going to be a format 3 instruction which uses immediate or PC relative or base relative addressing, where the operand address is specified in the form of a displacement relative to the either PC or the base register. But this doesn't work when we are using SIC program, where majority of the instructions are direct addressing or indirect addressing, wherein the complete operand address is specified in the instruction. So the majority of the instructions need to be modified. So adding up the modification records is going to be a troublesome thing. So for that reason, what we do is we use something called as a modification bit mask or the reallocation bit mask, which specifies in the text record how many of the operands in this text record need to be modified. That modification just adds the start address of the program to the specified text record. These are the two variations. Then we went on to learn the program linking, wherein resolving the external references and the definitions between the control sections. Control sections are the parts of the program, same program might be written in multiple source files, or you can think of different source files are combined together and they use the common variables. Then the variable defined in this section but used in the other section is called as external reference by the other program. We have seen an example which contains 3 programs or 3 control sections, program A, B as well as C, which has got few symbols defined in the current section but are referred by the other control section, and the other control sections contain the symbols defined in other control sections but used in this section. So these sort of external definitions need to be resolved. So the program, or means your assembler, just writes a modification records for all those operands which has to be modified according to your according to the uh, external references. And we have seen the algorithm of this algorithm is taking 2 passes to do this reallocation or resolving of the external references. So we use 3 data structures. Is ES tab, which is the external symbol table, which maintains the addresses of all the symbols which is appearing on the left hand side of your source code. And during pass 1, we're going to assign the addresses for all the symbols in a consecutive manner. See, after the linking and when it is being loaded, so the control sections are loaded in a consecutive manner. So first the first control section, next the next control section. For keeping track of this, we're going to use another data structure called as CS address, which is marks the starting address of each control section when it is being loaded. So actually the pass 1 is the definition pass, means to say it is assigning the addresses while loading, just like your assembler used the location counter to assign the addresses for each instructions. Right, but here it is not the assembly language code, but instead it is an code, means it is an object code that is getting loaded onto the memory. So initially, and along with that, we use another data structure called program address. The program address is the starting address that is given by the operating system where the program is supposed to be loaded. And the program address and CS address for the first control section will be the same, but the CS address will be added with the length of the first control section for the second what we call control section, and it will be added with the length of the second control section for the third control section, and so on it goes. Okay, and so in the first pass until the end is reached, we are going to be adding up the addresses for all the symbols that is being defined in each control section. The symbols defined in the sense all those symbols that is appearing towards the left hand side of the source code will be given an address starting from the load address or the program address what is given from the operating system. And in the pass 2 of the algorithm, we're going to take each text record and we're going to load it onto the specified memory location, and we'll use a modification record to find the absolute address of each of the operands, and we're going to load it onto the memory location. So this is what is the task of program linking. So looking at broadly this program linking, we are performing 3 tasks. Takes the object code that is given by the assembler, assign the addresses, load address or absolute addresses for each of the symbols that is being defined. Next, we're going to load the program or the object code in the specified locations. And the third one is we're going to do the linking. That means reallocation of the operand addresses according to the new address or the absolute address that is given by the operating system. So this much task is done. And if we look at it, if we have written a program, now we'll proceed further with the things. If you look at the program, you have written a program using some 3 or 4 control sections, let's assume, and each of them has a set of symbols. And this program you assemble, which assembler will going to take some amount of time for assembling it. Then again, you give it to the loader. The loader first in pass 1 assigns the addresses for all of them, and which takes some time. And after that, it does the reallocation of all the operands, which again takes some time. And it links all the symbols that is belonging to the different control sections. So the loading, linking, all these things is consuming more or equal time as much as the assembler has consumed for putting it onto the execution. And then the user can run the program. So obviously this compilation and load time will be more if we are going for program linking or linking loaders, what we can call it as, which does loading also as well as linking also. So after assembly time, the loading and linking will consume equal or more time compared to other sort of variations. So what I'm trying to tell you is, this is not an efficient way of assembling and loading and linking the program. Then what variations we can do? We can reduce the time of loading and linking by using some other variations. Actually speaking about This linking or program linking or linking loaders is not used in any of the production level compilers or assemblers. It will not be used, but we use the different variations. We shall see with the examples. That's what is the next part of our discussion. Okay, next we started with, I don't think so we started with this. So machine independent loader features, we shall see some machine dependent loader features, and then we go for the loader design options. So that's what is the major thing that you have to do. This is very simple, and this we all know, right? First and or the only machine independent loader feature is automatic library search, or we can call it as a library search. We all know, or we have used many header file inclusions during the while writing the program. From now onwards, we don't bother much about our assembly language. We shall bother about our high-level language. Yeah, for example, for using the library functions printf and scanf, we'll include stdio loader. Similarly, for using sqrt or some other mathematical function, we're going to include method.h. Right, and we would have used these functions in our program while writing our C program. So your assembler cannot identify because it don't know what is this function. It just assembles and leave it. When it comes to the loader or linker, your loader linker will not get the declarations of this printf and scanf functions, means header or prototype of this function printf and scanf in your source program, because you haven't written the source program for your printf and scanf because they are not user-defined functions, they are library functions. So how exactly these library functions are searched and is included in your program is what we call it as automatic library search. And you don't need to specify explicitly that find this function and attach it or link it to this program, but it happens automatically. That feature itself, we call it as what? Automatic library search. Let's go and understand this. Linking loaders automatically include the library routines, whichever you have used, for example, like printf, scanf, square root, and other things. Yeah, this allows the programmers to use the library routine by just specifying their name. So the user will going to specify, the programmer just specifies the name of the routine, where to search and how to include them. That is taken care by your linking loaders. Programmers mention the name of the library routine and it will be automatically included. This feature, we call it by the name library search. Okay, the library search keeps track of all the external symbols that are referred but not defined. Okay, we have in each control section this may happen. We might have used a variable, we might have used a subroutine, or we might have used a function, but that is not defined in the same control section. So it will going to be an external reference. So it will be marked as an external reference. That's what I mean by that. And that symbol or that function name, so whatever it is, a name of a function, a name of a variable, all of them are just identified or the user defined symbol. So that is going to get an entry into the symbol table. Similarly here, all these symbols which are not being defined, marked as not defined, will be made entry into the external symbol table. Okay, then what happens at the end of pass one, because in the pass one of your linking loaders, we're going to assign the addresses for all the symbols. So your external symbol table should need to get all the addresses of all the symbols which are defined by the programmer, right? Either in the same control section or in the other control section, you will going to get an address, absolute address. But now these function names or the identifiers or the symbols which are in the library, like your printf, scanf, or square root, will never get the address because they are not part of your source program. So they will be marked as undefined or unresolved at the end of the pass one, because we don't get those symbols in the user written program. So then we come to know that these unresolved symbols should be searched in the libraries. So in those libraries which we would have included the header files. See, header files will not contain the library functions. Header files just contains the prototype of the function. That's all. It will not contain the function itself. The function body would have been defined in a separate file, or it means in a separate file which will be stored in your Unix operating system in means /lib. Okay, libraries will be stored there. But the header or the prototype of that library will be stored in the header file. That's why we call the file as header.h. It's a header file, not a function or library file. We don't call it as library file, we call it as header file because it just contains a prototype and the pointer to the definition of that particular function. It will contain the header and the pointer to the definition of the function. So we will start search in those particular library files where this function definition would have been present. So now these functions will going to get an address, means this will be included or this will be linked along with your source program, means this will also be loaded along with your source program to the specified address. But actually it's wrong. We're going to see the variation. But as of now, we just assume that this function definitions means to say, if you have told hash include stdio.h, all the functions of stdio.h, including printf, scanf, printf, scanf, all of them will going to be, means those definitions will be loaded on along with your source program onto your memory. So when it is loaded onto memory, now these unresolved symbols for printf, scanf and all will going to get the address in your external symbol table and it will become local. So you can use them as just a local variables, but you haven't written them, but you haven't defined them, but that's it has been predefined. You are just using it. That's why we call it as a predefined function, and user-defined functions are separate. Library functions and user-defined functions. Library functions are in the form of object code, which can be directly included with your source program. Got the idea? So that's what we mean by library search. So once after this, if some symbols, the unresolved symbols will be searched recursively in the libraries. Why I am telling you this word? Because recursively means because we are going to have a set of library functions under a single header file. It means it is going to be stored in the form of a folder structure, and folder contains a subfolder, subfolder contains a subfolder, so on. So it should search all the subfolders recursively so as to get the library function. So means all the folders will going to be recursively searched. If it is found, it will going to be it will be loaded, and its load address will going to be entered into the external symbol tables. Then it will use a local thing, you can use it. But if it is not found, obviously then it is a mistake. So then you will going to get an error, something like undefined function name or undefined identifier name, right? How exactly this works? Yeah. So then once it is loaded, it is going to be used just like a local variable, and the program works well. But there is an option that the programmer can override the library routine. For example, you have a library function called sqrt, which is a built-in, and you have included math.h, and you have used sqrt function. But you don't want the sqrt function of what you call present in the math.h, means a library function. But you want to write your own. You can write, obviously, you can write sqrt and function definition. You can declare the header of the function and definition of the function. Then you have declared, and there is no need for your loader to go and search in the library routine, because already before it goes and search in the library routine, your ES tab or external symbol table would have got the symbol along with the address because it is defined. So you can override. You can override the name of the function, which is library, than user defined. So highest priority is given for your user defined functions, because it is not found as an user defined function. If the symbol is not found in local, then only we go and search in the library function. So which is a ternary task. First search in the current source file, current control section. If not found in the second control section, if all the control sections are searched, still the symbol is not found, then as a ternary choice, we go and search in the library routines. If there also it is not found, then the symbol is not defined. That's what is a simple thing. The libraries contains the object code. Yeah, that's what we call it as pre-compiled code or pre-assembled code will be there. Usually organized in the directory structure, just like as I have mentioned. And this directory will have the name of the routine as well as the pointer, because your header file will have only the prototype, and that prototype will point to the definition of your function, right? Pointer. So this is about the machine independent loader feature. Majority times it is asked for your what you call short note sort of thing. It's just a conceptual thing. You don't need to prove this by writing an algorithm or anything. It's just a conceptual thing, how the libraries are included in the linking loaders while the program is being loaded, right? Okay, this is one of the concept which we should know as a programmer how exactly this happens. But in specific, while teaching programming, we don't teach you these things. So that's why this is supposed to be explicitly taught in the system. Right. Let's move ahead. Yeah, very important thing in this chapter is this particular things, and these are not an imaginary concept. These are the very realistic concepts which we use every day. The loader design options. Fine. We shall see. We have something called linkage editors. Earlier to this, we just whatever we learned, the linking loaders or the linking loaders, which does the function of reallocation, the function of linking, the function of loaders. These three tasks is done in two passes. We have studied the algorithm and we have studied the data structure, which is something like a very basic design of the linkers and the loaders. Both linkers and loaders together is making up a single system software, which works immediately after the assembler produces the object code, which does the task of linking, task of reallocation, and task of loading of your object code to the memory. And now after this task, your program is ready to be executed. Fine. But when we talk about absolute loader, your absolute loader don't need to do linking, don't need to do reallocation because it's an absolute. Just copies and paste. Very basic, bare functionality. The second level of functionality is, it is relative, point number one. It is having some set of control sections. It is having external definitions and references. So for that reason, we need to load it, get the addresses, then link it, resolve all the operand addresses by using reallocation. Fine. That's the second option. That is your linking loaders. But as I told, the linking loaders will going to consume space. And linking loaders can also search in not only in your control section, it can also search in the library is for the undefined symbols or undefined identifiers. That's what we learned in the machine independent assembler features. Now let's see the optimization or the various ways the loaders and linkers can be designed so as to optimize them. One of the method is called as linkage editors, widely used. Fine. Yeah, before going for this, I'm going to tell you one thing that we usually use. What we do, we'll write a C program, something like program1.c, compile it. After compilation, we're going to get an executable file that is a.out. How we'll run? By just giving ./a.out. If you remember the steps of compilation which I have told, the first step is your macro expansion. After that, your expanded source code is given to your compiler. Your compiler will going to give a reallocatable assembly language code, which we call it, which is going to be the outcome of your compiler. Compiler gives assembly language code after 6 phases of the compiler. This assembly language code is then given to your loaders and linkers, and after that, you will going to get a executable file that is your a.out. So this a.out don't need to be compiled every time. Am I correct? Because it is not a C program, it is a a.out file. So you don't need to compile them, you can execute any number of times, correct? So that means to say your a.out file, and remember your a.out file is not in the memory after the compilation and loading and linking. It is not in the memory, it is there in your secondary storage device, that is your hard disk. And you tell ./a.out means the present directory, run the file a.out. Then the loading happens. Means to say the loading is a different task that is happening. The reallocation and linking is a different task that is happening. The reallocation and the linking happens as a consecutive process after your assembly. Please try to understand. The linking and reallocation is separated. The linking and reallocation happens separately, and just like an absolute loader, or loader will be used, it will take the absolute address, means which will take the load address from the operating system and just places your linked program, reallocated and linked program onto the memory. Just copy and paste. That's all. So means to say your program linking loaders was doing 3 tasks. First is it used to do reallocation, it used to do linking, it used to do loading also. All these 3 things are mixed up. So now we are separating one task for it. That is, loading is separated, reallocation and linking is separated. Reallocation and linking is happening just as a next task after your assembler is giving a object code. What I mean is reallocation, linking, library search, all these things would have happened and it is returned to a separate file. That file we call it as a.out. You can rename also, you have that option, you can rename also. So which is not only the assembly language object code. Remember, your a.out is not an assembly language object code. It is an assembly, it contains assembly language object code, and the linking has been done, means all the external references are being resolved and it is ready for execution. Can execute when it is just loaded onto your memory, right? So such sort of editors or such sort of loader option is called as linkage editors. That's the overall concept, but how exactly it happens, we just need to put the light on it, right? Means the loading is a separated and your program is after assembling will be linked and reallocated. External references and everything will be resolved and your library functions will also be resolved. Yeah, we shall see further. Linking loaders performs the task of linking, reallocation, all these things during load time. At the same time, it is doing loading, linking as well as reallocation, but it is a time constraint. This can be performed in 2 alternative ways. What are those 2 alternative ways? One alternative way is called as linkage editors, which performs linking before load. All the linking and reallocation and library search would have happened before the loading of the program. But in the earlier case, all 3 would have happened, should be done during the load time. So that will going to consume a lot of time. Next variation, dynamic linking. Actually, we are using the last option. All the compilers will going to use, including your GCC compiler, will use this dynamic link, which will go into link not during compile time, but during the runtime, during execution time. That's what is the variation. Okay. Okay, fine. Proceeding further, linkage editors are found in many systems. We use this. It performs a linking and reallocation, both the tasks, just after the assembler has given you the object code and writes this code into a file. That's what is our a.out file or library, instead of directly loading it into the memory. So we're going to link and do the reallocation and write it into a file. Such sort of linkers are called as linkage editors. Okay, this reduces the overhead during the execution of the program because all these 3 tasks should be done and the beginning only I told, which is consuming equal or more time compared to your assembly. Right. Example, a.out file which has been created in our C program. Right. That's what is the example. Okay. Difference between the linking loaders and the linkage editors. This is what is happening. Your object programs given by your assembler will be given to the linking loader, which will search your library, do the reallocation, do the linking of all the external symbols and all, and directly places into your memory. Yeah, linkage loaders takes the object code from the assemblers, then link, reallocate, automatic library search, all this task is done, and immediately it will be loaded into your memory. But see the difference? The linkage editors will take the object program, it will also look into the library, and this linkage editor will going to create a separate file, which we call it as a linked program. That is what I mean by your a.out, linked program. And then a small loader will be used, similar to your absolute loader, but with some additional capacity of doing the reallocation, because we don't know what will be the load address, but in the absolute address, it will be loaded in the absolute address. Every time it should be loaded into ATH1, it will be loaded into ATH. But we may not know because it's a user program where it will be the address will be given. So we should have an absolute loader, is similar to absolute loader, but which can add up. Just it need to do is take the load address, add to each of the symbols or add to each of the instructions and then put it into the memory. That's the difference. The one step that is extra. What is the advantage is every time you want to run the program, you just need to call the reallocating loader to load it into the memory in the address specifier. That's the only thing need to be done with the case of what? Linkage editors. But with the case of our linking loaders, every time you should start from all these steps together. You should take the object program, link it, resolve the external references, all these things should be done. If a program is compiled once and running many times, the linkage editor is better, which will be the usual case. We write the program and we run it many times. Linkage editors is better. But if every time the program need to be compiled and assembled, linked, loaded, then the linking loader is a better option. So it reduces, the linkage editors reduces lot of overhead that was usually happening during the loading and execution of the program. Fine. This is one of the loader design option, that is linkage editors. Next we shall see about the dynamic linking. So that's what is being done. During execution, simple reallocating loader is used, which adds the load address to the relative address, and the linking editor performs the reallocation of all the control instructions related to the start of the program and all the operands. Let me think that we have three control sections. We usually in the linking loaders earlier we used to get the operating system address from the operating system, and your loader used to run your pass one concerned with the address what is it. But now your loader will now your linking and reallocation will have starting with the address 0000, and all the operands will have been given the address relatively starting from 000. So what need to be done during execution is you should add the load address. If 3000 is a load address given, 3000 should be added to the all this. 5000 is given, 5000 should be added to all the address. That's how it works. So this entire loading is performed in one pass, because take the text record, add 3000, put it in memory. That's all. Take the text record, add 3000, put it in the memory. That's what this is supposed to be done. Okay. If the program is executed many times without reassembly, linkage editors has less overhead. The external references and library search is done only because the external references and library search is done only once. Okay. Yeah, it's not a good option if the program is reassembled many times. That's it. Okay. We shall stop here and we shall continue in the next class.